Hello everyone, I'm Tori, a developer advocate from the Container Services team at AWS. So today's topic is, as you can see, security. We are going to talk about how to utilize the full spectrum of Amazon ECS's security features and its tight integration with AWS's security features. So before diving into security topics, we are going to recall some very basics about Amazon ECS for a few minutes, I think, so that we can make sure that we're on the same page before we're going through the main topics. Okay, so let's get started. So Amazon ECS is a fully managed container orchestration service. With Amazon ECS, you can choose between or use both EC2 instances and AWS Fargate managed servers as a place to run your containers. When you want to run containers, all you have to do is just call an ECS API. Then ECS runs your containers for you in the servers like this. Sometimes you may want to use ELBs to route traffic from the internet to your containers. Yes, you can do this. ECS also takes care of registering your containers to the load balancer as its routing target. It's like a magic, right? But actually, as you may know, it's not a magic. Let's quickly take a look at what's behind it. So, there are at least two daemons running in each server: the ECS container agent and the container runtime. Docker might be one of the most famous container runtimes out there. So the ECS agent in that server talks to ECS, and ECS tells the agent which containers should be running in that server. The ECS agent then tells the container runtime that we want to run containers. Then the container runtime downloads the required container images from container image registries, such as Amazon ECR or Docker Hub. And then finally, it runs the containers. The container runtime is also responsible for other things in this diagram. For example, forwarding container logs to somewhere like CloudWatch or anywhere else that users have specified beforehand. So I mentioned that you may call ECS APIs to run your containers, but more specifically, you may use the Run Task API or the Create Service API to do so. A task is the smallest deployable unit in the ECS world, and it consists of one or more containers. So for example, an Apache HTTP container and a Tomcat container can be packed into one ECS task. So you define how you want to structure your tasks by writing a task definition, which includes container definitions and other configurations for containers to run, such as networking, storage, and computer resources. And a service on the right side. It's another ECS construct to enable us to run a set of ECS task replicas. So let's imagine something like a long-running application. Like web or API servers, you may need to run a required number of replicas and want them to keep running. You may also want to make sure that it will be recovered automatically if some of the replicas unintentionally stop. In this scenario, you will use ECS services to run your task. And finally, there is cluster in Amazon ECS. This is a logical group of ECS resources like ECS tasks and services in an AWS region, and it can work as IAM permission boundaries. We're going to cover it later. So okay, now you know that an ECS task is the smallest deployable unit in ECS, So let's make sure that you can run your Amazon ECS tasks securely to start with. So let's imagine a scenario where you've joined a new team in your company, and your job in this team is to make sure that your team's containerized application on ECS is running and operating securely. So here's a simple diagram you got from a team member which describes your ECS app very briefly. User traffic is coming from the A or B on the left side to the ECS tasks, which run as an ECS service. And the ECS tasks look like they are running on EC2 instances and are also using S3, Aurora MySQL, and SQS. So where to start? You may know some basics about AWS like security groups, so let's take a look at them to begin with. So in this diagram, security groups can be used with the highlighted resources. So you checked the current configurations in the AWS Management Console and wrote them down in the diagram. Look, as highlighted on the table, both security groups for the ECS tasks and the database instance allow all incoming access from within the VPC. You've asked the reason to your coworker, but he or she said there's no specific reason for it. Okay. It's not super bad, but it could be better. So let's make it a bit more secure. Okay, look. So with these updated configurations, the ECS tasks only accept traffic from the A or B, and the database, this is important, can only be reached from the ECS tasks. See? Much better. Okay, let's move on to the next topic. So the ECS tasks use a database. So this means the tasks are using credentials for accessing the database. Classic. You've heard from your teammate that they are passed by environment variables to the tasks. So let's take a look at the ECS task definition here. Oh, look. The credentials are actually on the environment variables. But this is, not good, right? Okay, so using environment variables is a good way to pass parameters to containers, but it's not actually good for credentials. Why? If you put them in the task definition, anyone who has access to the task definition can know the credentials super easily. So in this case, instead of writing credentials on the ECS task definition, we should consider using AWS Secrets Manager, for example, to store such credentials securely. And those stored credentials can be read and passed to container security by using the ECS Secrets integration. So let's store the credentials in Secrets Manager and update the task definition to reference them. Take a look at what we have changed. Now we wrote ARNs in the value from fields under the secrets field to reference these secrets values in Secrets Manager, instead of revealing them in the task definition. With this configuration, ECS will automatically fetch the credentials and inject them into your containers. Plus, you can do this without modifying your application. That's cool, right? So now you have successfully hardened security groups and secrets access. So let's take a look again this diagram to find what next. So how about us taking a look at another foundational AWS feature? It's IAM. As you can see, the ECS tasks do access the S3 bucket and the SQS queue, which means somehow the ECS tasks get IAM credentials to access those AWS resources. To begin with, let's figure out how the ECS tasks get the IAM credentials. You probably know that you can define an IAM role in each ECS task definition to let ECS pass an IAM role to each ECS task. So let's take a look at the ECS task definition again. From what we are seeing now, there are two role-related fields in the task definition, but each of the values is empty. This means the ECS tasks are not using the ECS feature to get IAM roles at this moment. So the question is, where did they get the IAM roles from? Yes, it could be a role of the underlying EC2 instance. As you may know, an EC2 instance can be configured to have its own IAM role, and containers running on that EC2 instance can use the EC2 instance role to get credentials, just like other non-containerized applications. So let's open and see the attached IAM role to the EC2 instance in the management console. This is it. It looks like it has the IAM policies which allow full access to S3 and SQS. So your ECS tasks are accessing those AWS services using this EC2 instance role. But wait, this setup works for your application, but it's hard to say it's good from the security perspective, right? You may be able to run multiple different ECS tasks in a single EC2 instance as described in the diagram, which means all ECS tasks on the same EC2 instance can use the same EC2 instance role. Let's say you only want to allow the ECS task on the top to access the S3 bucket and SQS queue, but actually both ECS tasks can use the EC2 instance role to access those services. Is this what you really want? I don't think so. So this is the best use case that you may want to use IAM roles for tasks to grant permissions at the task level instead of the underlying EC2 instance level. Let's do it. As you may have realized in the previous few slides, the original permission granted too wide of privileges. It's granted full access to S3 and SQS. So you asked your coworkers to know what the actual necessary permissions for the applications are, and created modest policies which grant least privileges. Then you attach those policies to a newly created IAM role, which was specifically created for the ECS tasks. Then finally, you reference them in the task definition. It's perfect, right? Now, your ECS task has its required IAM permissions at task level to access other AWS services, and it works as expected. Cool. Okay, give me a minute to explain something here. So I won't go deeper than this page, but it's good for you to know that there is a similar but different IAM role in the ECS world. So if today is not your first day learning about ECS, you may have heard about ECS task execution role before. Task execution roles and IAM roles for tasks sound very similar, but they are actually different models. So understanding their differences is very important in running your tasks securely. So let me explain a little bit before we take the next step. So on the left, we have IAM role for task, also called task role for short, which is a role for the task itself This means that role will be used by your application in the task. And then we have the task execution role on the right side, which is another task level role, but this one is not actually for the task itself. It is to allow the ECS agent or the container runtime to make AWS API calls on your behalf. As described in diagram, the ECS agent uses it to access secrets manager and lets the container runtime pull container images or to send container logs. Make sense? Okay, so what's next? I think you may have realized that we haven't talked about logs yet, right? Logs. I believe most of you think that logs are very important not just only for debugging but for forensics. As you may know, containers are very ephemeral by its nature. Or maybe we should say here that we should treat them as ephemeral things to leverage the benefits of containers. So we need to take care of preserving application logs outside of containers or its underlying hosts. So let's take a look. So Docker has a mechanism called log driver to collect containers standard out and standard error outputs and to forward them to a specified location. Amazon ECS supports the logging driver, and the task definition here looks like it's configured to use the AWS log driver, which means it's going to send all standard out and standard error outputs from the container to CloudWatch logs. CloudWatch logs is an AWS service that allows you to store, find, and access your log files. So you'll be able to find and search through them via the CloudWatch logs APIs or the management console like this. This is good enough for the time being. Your application logs are stored in CloudWatch logs, so you will be able to figure out what happened after the ECS task stopped. So this may stray slightly off of the main topic, but let me introduce another example here. So as we saw in the previous slide, storing all logs in CloudWatch logs is good because you can find your logs whenever you want. But there are many good use cases for using log data that are not limited to security use cases, like analyzing logs to find recent access patterns with Elasticsearch and Kibana, like this. Or sometimes you need to store logs for a certain period of time, like months to years, for the purpose of auditing or to be compliant with government regulations, for example. So CloudWatch logs has a feature called subscription filters for this, that allows us to send logs stored in CloudWatch logs to other services like Elasticsearch or S3 as required. In addition to that, it's worth taking a look at an ECS feature called fire lines if you need more advanced log filtering and routing. Okay, let's move on to the next topic. The next step will be something about container images. We won't be able to cover this topic in too much detail today, but we'd recommend that you enable at least 2 features in each ECR repository. The first one is immutable tags. As you may know, container image tags are not immutable as its default, so enabling this is an effective way to prevent using unexpected container images in your ECS tasks. Also, image scanning is effective for handling CVEs for the container images. So please take a look at the blog post which covers this story and how to do it with some example code. Okay, let's summarize what we've learned so far. You may realize now that we need to think all the way from container images through to the ECS task level when we talk about security of ECS applications. And we didn't cover too deeply about container images and containers themselves today, so I would recommend that you to read this great blog post from Docker for more details on that. So you have hardened from your container images to the ECS tasks. Is your job done now? No, not yet. What if someone else in the team deletes the ECS service by mistake? What do we need if another team also wants to use ECS to run their apps? Right? So hardening the ECS task itself is not enough. We also need to make sure your ECS tasks continue to operate securely. From that perspective, we're going to look over these three topics today: access control, auditing, and validating AWS resources. Just to make sure, we are focusing on ECS today, but all the following topics are actually valid and useful for other AWS resources as well. Okay then, let's go. So as I mentioned before, you need and want to make sure that whoever accesses ECS in your organization has been granted the appropriate permissions. With AWS IAM, there are multiple ways you can control each user's access to the ECS APIs. So let's look over them with examples. So the first one is very simple. As you can see, you can grant read-only access to the specific ECS cluster for your ECS users. This is very basic but still a useful mechanism for better access control. And next, we can use a condition in IAM policies. So let me explain a little. So this IAM policy basically allows all ECS API calls that start with describe or list. So a user with this IAM policy can call ECS APIs like describe clusters, describe tasks, list clusters, or list services, for example. But it's actually not for all ECS resources. You may realize that there is a condition field next to the action field, and it narrows the range of accessible resources. So in summary, a user with this IAM policy can describe or list anything, but the access will be limited to resources in the specified ECS cluster by the condition field. Good. And the last one is a bit more complex than the previous examples, but it's a powerful mechanism. It's called ABAC. So let's say you want to allow users to call ECS APIs, but only for their own ECS resources. I think this is one of the most typical use cases where multiple teams in an organization use ECS at the same time. In this situation, you may use ABAC to achieve the goal. With the IAM policy in this example here, all users allowed to call any ECS APIs only when the two tag values match: the owner tag value of ECS resource and team tag value of IAM user. This is very good, right? Okay then, let's go to the next step. So now you have configured all IAM policies for users in your organization properly, but also you may want to ensure that AWS API core events that occur in your AWS account are logged for governance, compliance, and operational risk auditing of your account. You can use another AWS service called AWS CloudTrail to achieve this. As you can see, with CloudTrail, you can find AWS API calls to know what and when actions were taken by a user or a role. This is very useful to keep track of AWS API calls to audit activities in your AWS account. And this is a diagram that shows an integration pattern. You can use the CloudTrail API or the management console to do ad hoc auditing. And CloudTrail also supports exporting events logs to S3. So you can use services like Amazon Athena to do regular analysis and auditing, for example. And here is the last topic to make operations in your organization secure. So up to this point, you made a number of changes to improve your team and system security posture. But I believe you may also need to validate continuously to keep your configurations compliant with the security level required in your organization. So I would also like to briefly introduce to you AWS Config. I again can't go into too much detail today, but it's worth remembering at least its name. As you can see, with AWS Config, you can find resources with unwanted configurations or maybe automatically remediate them to be ideal states. So take a look at the AWS Config documentation and the samples in the GitHub repository as well. And the last topic of this session, I would like to quickly show you some steps you can take going forward to further secure workloads. Automation. This is one of the most powerful and effective ways to make sure that everything is done robustly and securely. So please also watch the related session for a deeper dive into this topic. And AWS Fargate. So Fargate is a serverless compute engine for containers that works with Amazon ECS, and it removes the need to provision and manage servers and allows you to focus on building your applications. But it also gives you security benefits by its nature. I believe it's worth watching these breakout sessions to understand how AWS Fargate can help you. Okay, let's recap. So when it comes to securing ECS applications, we should think about it from two aspects: the ECS task itself and its operations. And automation, this is often discussed out in the world from an agility perspective, but avoiding manual operations is a very good and effective way to improve the security level of your operations as well. And finally, you can use all the ECS features we covered today without installing any additional software. So let's get started today. Thank you so much. Please take a moment to take a survey and have a great reInvent.